So a perfect square binomial meets this form. Note that you could have a could be -3 because -3 squared makes a positive. So we could have a negative term in here. Don't be fooled by this plus sign because you could think about a negative a or maybe a negative b. Okay. Basically what we were looking for is something so that when we factor, you would get something like this. That's a perfect square because the two factored pieces would be the same. So you could try to factor each of these. Take some time, but you could go through each one, or you could try to use the fact that a perfect square trinomial meets this form. Okay, so if we let a be 4 and b be 4, I got that really quickly by taking the square root of this number and the square root of this number. We can choose one to be negative. That's not going to help us though because we need this to be. Yeah, no, we could choose one to be negative to make -64. Let's see what happens. Because this middle term, it has to be 2 times a times b. So if this is 2 times a times b, then we might be in business. But 2 times 4 makes 8. 8 times 4 makes 32. So this is not possible with our a and with our b. This is out. Okay. Here, not possible because here, well, we could factor. It's not a perfect square of a binomial here. Because if you could factor out the -1, and that would be -6x plus 3. Even if you do that, x minus, no, there's no way to factor that into a perfect square trinomial. But yeah, I guess there's nothing else to say about this one. If there's a negative sign, I'm trying to be confident and say that there's no way you can write it as a perfect square of a binomial. You could factor it, but I think for this question, it's saying, without factoring, is this a perfect square binomial? It's not, because it can't identify an a here. This next one, same thing. Take a square root of the first number and a square root of the last number. And so see if those can make this make 15 when we plug it into the middle part of the formula. 2 times 5 times 3, that makes 30. So no way for that to happen. This one's out. A would have to be 5, maybe positive, maybe negative. B would have to be 3. And so if we plug that into the formula, it's 2 times A times B. That would make 30, so that's not going to make what we're looking for here. Oh, sorry, A would be 4. Whoops. A would be 4, B would be 3. 2 times 4 makes 8. 8 times 3 makes 24, so that's not going to work out. This one's out. It's got to be this last one. A would be 7, B would be 4. And then 2 times 7 times 4. 2 times 7 makes 14, and 14 times 4 makes 56. So that checks out. This is a perfect square trinomial. You could let A be -7, or you could let B be -4. Either one, and you'll get to the right answer. So if you factor this, it's going to be 7x minus 4 squared. Okay, and then you could check that I made B be negative in that case. You could check it by multiplying those together. That gives us 49 minus 49x squared minus 28x minus 28x plus 16. So that makes -56 when you combine those like terms. So that's our winner. That's the one that makes a perfect square by a binomial when you factor it. So we're asked to factor here. This is a perfect square because these two numbers are numbers we can find the square root for without using decimals, decimal approximations. And then because there's a minus sign in the middle. Those two criteria need to be met, because you could think of this as having a middle term. It's just 0 for a coefficient. And you could use your normal factoring methods. You would just have a y on the end instead of an x. You'd multiply the leading coefficient and the last coefficient. Quicker way to do that, though, instead of doing this method where you multiply those together and you got to find two pairs that add up to be 0. The square root of the leading coefficient here, so the square root of the coefficient for x squared is 11, and the square root here is 9. The square root of 9 is 3. I'm having a hard time talking today. And for the middle term to cancel out, I was about to put x squared, but that wouldn't work because we'd have a middle term. The only way you're going to make that middle term cancel out is if they have opposite signs in the center. And so now if you multiply these together, 11x times 11x makes 121x squared like we were looking for. And 11x times 3y makes 33xy. And then this is going to be minus 33xy, so those middle terms cancel out. And then negative 3y times 3y makes negative 9y squared, just like we wanted. So this is the factored form. This is the answer we need to give them.